All right, let's get right into it. Today we're looking at some research that might just be the key to unlocking truly useful AI assistance. It's a project called Agent World, and honestly, it could be the training ground of the future. You know the feeling, right? You ask your phone or your smart speaker to do something that feels like it should be simple, a task with a few steps, and it just gives up. You end up having to do it all yourself anyway. So what's the deal? I mean, we all have this vision of something like Jarvis from Iron Man, this brilliant, seamless partner that just gets what you need. But the reality we live with is that dreaded phrase, sorry, I can't complete that task. There's this massive canyon between the dream and what's actually in our hands. And the researchers behind this paper have this perfect analogy for the problem. They say, current AI models are like brilliant pilots who've passed every written exam, but they've only ever trained on a cheap, totally unrealistic flight simulator. They know all the theory, but they have zero real-world experience.
So yeah, let's just put a name on it. This is the core bottleneck we're up against, the AI assistant problem. And it's what's really holding us back from the next big leap in AI.
So why is this so hard? Well, it really boils down to a few key things. For starters, there just aren't enough realistic digital worlds for these AIs to practice in. And trying to build these worlds by hand, it's painfully slow and super expensive. The simulated worlds we do have are often way too simple, or just flat out wrong, which teaches the AI bad habits that are useless in the real world. But what if you could build a better training ground? A much better one. Well, that's exactly what a team from Renmin University of China and ByteDance decided to do. And their solution is called Agent World. Okay, quick sidebar here, just so we're all on the same page. When we talk about an AI agent, we don't just mean a chatbot. We're talking about an AI that can actually use digital tools, things like APIs, websites, and databases to actually get stuff done. And this is the whole philosophy behind Agent World. It's not just another simulator. The creators call it a living, breathing virtual world for AI to grow up in. And that wording is so important. It tells you they're trying to create something dynamic, complex, and always changing, kind of like our own world. So how in the world do you build something like that? Well, the first step is to create a truly massive and realistic universe of tasks and environments for the AI to get its hands dirty in. And when I say massive, I mean it. Agent World is built on nearly 2,000 unique, realistic environments. And these aren't just made up either. They're pulled directly from real-world sources, actual tool documentation, server specs, product requirements. Everything is grounded in reality. And look at this. What's so cool is the sheer variety. We're not talking about just one type of job. These environments cover 20 different categories, everything from finance and crypto to travel, healthcare, and software development. It's like sending an AI to the world's most comprehensive university. This slide gives you a bit more of a feel for that variety. The word cloud really pops with some of the skills the agent is learning, how to interact with GitHub, weather APIs, trading platforms, and the other charts show you just how different the tasks are. The takeaway here is that the training isn't just broad, it's also incredibly deep and complex.
But here's the thing, building this gigantic, realistic world, that's only half the battle. The truly revolutionary part is how the AI learns inside it. This is what they call the smart training arena. And this is the secret sauce. Instead of just throwing 1,000 problems at the AI, Agent World creates something they call a co-evolution loop. Think of it like a personal coach for the AI. First, the agent tries a task. If it fails, the arena itself figures out exactly why it failed. Then, and this is the amazing part, it automatically generates a brand new task specifically designed to fix that one weakness. The agent tries again, learns, and gets smarter. It's a constant feedback loop. Now, this diagram from the paper looks pretty technical, I know, but you already understand the core idea. You see the agent up top, the environments on the right, and that cycle we just talked about. Try, fail, diagnose, and evolve. It's a self-improving system where both the AI and its training ground are getting smarter at the same time. Okay, so the theory is fantastic, right? A huge, real-world training ground with a smart, adaptive coach. But the big question is, does it actually work? Does it create a better AI agent? Let's look at the results. And the answer is a huge yes. This chart shows one of the most important findings. The agent's performance gets better in direct proportion to how many environments it trains in. As they added more worlds for it to learn from, its accuracy more than doubled. It's simple, really. More diverse experience leads to a more capable agent. And get this, it's not just getting smarter.
It's getting smarter efficiently. These charts compare the agent world model, in blue, against other, much larger models. And on these really tough industry tests, the agent world model just consistently comes out on top. It proves that it's not about raw size, it's about the quality of the training. This slide perfectly illustrates just how well-rounded the improvement is. These are called radar charts, and they show the agent world model, in blue, has this balanced, solid improvement across a bunch of different skills: reasoning, coding, using search tools. It's not a one-trick pony. It's becoming a true generalist. So when you put all this together, when you zoom out, what does this actually mean for the future of AI and for us? Here's the bottom line. This whole project isn't just about getting a higher score on a test. It is a blueprint for a massive shift, a shift from AI that can just talk about doing things to an AI that can actually do them reliably and effectively out in the messy, real digital world. And that leaves us with this one really exciting question to think about. What becomes possible when the next generation of AI can learn not just by talking, but by doing, by acting, failing, and evolving inside a world that's just as complex and dynamic as our own? That's the future agent world is pointing us toward.